This is Unit 3, Day 2, and factoring. Okay, so when you guys think of the word factor, there's 3 important things in your factoring toolbox that you should remember. We learned greatest common factor, we learned the difference of perfect squares, and we learned how to factor trinomials. Okay, so we have GCF, DPS, and trinomials. Okay, so this first one takes you back to literally like middle school. We probably haven't done this in a very long time. And it says factor each of the following integers completely. In other words, write them as a product of only prime numbers. This is also called prime factorization. So I don't know if you remember from middle school, but we used to have factor trees. So in your head, you're just thinking of what 2 numbers multiply to give you a 12. You could pick 3 and 4. You could pick 1 and 12. You could pick 2 and 6. It doesn't matter, okay? You could pick 2 and 6. Your neighbor could pick 3 and 4, but you will end up with the same result. Okay, so 2 is prime, so you know that's done. But 6 is not, so that's a composite number, so you have to break that down. And 2 times 3 is 6. Now I'm left with all these numbers. So I have 2 2's, so we write that as 2 squared times 3. And 2 squared times 3 is 12, so that's my answer there. Okay. 30. You could think of something such as like 3 and 10. Okay, 3 is prime, so you know to stop. But 10 is 2 times 5. So you have a 2 times a 3 times a 5. Okay? Alright. So I think you pretty much probably know how to do this. But I want to just teach you a way on your calculator as well. On your calculator, let's say you pick 6, or actually I'll do this one with you. 6 times 6. And you have 2 times 3, and you have another 2 times 3. So you have 2 2's, so that makes that 2 squared times 3 squared. The shortcut on your calculator, if you hit menu, 2, I think 2 is number, and then 3 says the word factor. So menu 2, 3, you put in any of these numbers, like if you're doing part A, you put menu 2, 3, it says factor in your calculator screen, and then you put in a 12, so it'll say factor 12, you hit enter, and it gives you 2 squared times 3. That's pretty awesome as well. Okay? Alright, so in the study of algebra, there are certain skills that are called getaway skills because without them, a student could simply could not enter into many more complex and interesting problems. Perhaps the most important getaway skill is that of factoring. The definition of a factor in 2 forms is given below. Okay, so factor means to rewrite a quantity as an equivalent product, meaning what times what can give you that. Factor as a noun is any individual component of a product. Okay, so for example, 2 squared times 3 are the factors. Okay, it's in its factored form, but 3 is a factor as well as 2 is a factor. Okay, so now we get into example 6. Rewrite each of the following binomials as a product of an integer with a different binomial. So this is basically our greatest common factor. So you're going to look at 5x and 10 and say, what can you divide out of both numbers? Now you can't say 10 because you can't take 10 out of 5. But I can divide out of 5. Okay? For my visual learners, that means you have to divide each of those by 5, and you're going to write what's left over in parentheses. So 5x divided by 5 is x, and 10 divided by 5 is 2. To check to make sure you did it correctly, redistribute this. 5 times x is 5x, that checks, and 5 times 2 is 10. Okay, so we just did the greatest common factor. Alright, 2x minus 6. I can divide out a 2, and then if I divide each of these by 2, I'm left with x minus 3. Again, check in your head, do a little mental check, and redistribute that to make sure you get 2x minus 6. Alright, the next one I can divide out a 3. Be careful. I'm left with 2x plus 5. Okay, and then 6 and 14, you could divide out a 2, and you're left with 3 minus 7x. Okay, pretty easy. The above type of factoring is often referred to as factoring out the greatest common factor, GCF. We kind of talked about that, so I'm going to jump over it. Example 7. Write each out of the following binomials as the product of the binomials GCF and another. So this is exactly what we did up top. But now you have a number and a variable that can come out. Now remember, this one has 2 of them because it's x squared. This one has 1. You can only take 1 away. You can't take 2 out of something that only has 1. So I'm going to divide each of these by 3x. So 3x squared divided by 3x, my 3's cancel. I'm left with an x. And again, do a little mental check. 3x times x is 3x squared. Okay, over here, my x's cancel, and I'm left with a 2. Please do a mental check by distributing to make sure you get that. All right, part B here. I can divide out a 5 and an x from both of them. Okay, so over 5x, over 5x. X's cancel. I'm left with 4 minus x. Part C. 10 and 25, I can only take out a 5. X squared and x, I can only take out an x. So my GCF is 5x again. So 10 divided by 5 is 2. X squared divided by x is x. Carry the plus. X's are gone, and 25 divided by 5 is 5. Okay? All right. It looks like 10 is the only thing they have in common. So if I divide each of these by 10, 30 divided by 10 is 3. X squared comes along for the ride, minus 2. Okay? Hopefully, I'm dusting the cobwebs and GCF and factoring is coming back too. Okay, example 8, rewritten in factored form. You're doing the same thing. So 20 and 36, you're going to try and think of the largest, the greatest number that you could divide out of both of those. Well, rather than doing that, a little shortcut here is just distribute these and see which one gives you this answer. Okay, so if I look at choice 2, I know that 4x times 5x would give me 20x squared. And I know that 4x times a negative 9 is going to give me minus 36x. So you really didn't have to think about it. You could just try out all of your choices there. All right, example 9. Trinomials can also sometimes be factored into the product of a GCF and another trinomial. So my leftover is a trinomial. Rewrite each of the following trinomials as the product of its GCF and a trinomial. Okay? So basically you're looking at all of these numbers and you're deciding what can I take out of a 2, an 8, and a 10. Well, it's going to be a 2. So I'm going to divide each of those by 2, and now I have to write the leftover. So I'm left with x squared plus 4x plus 5. Stop here. I know that eventually we're going to learn how to factor trinomials, but you're going to stop there and you just write your leftover. Okay? So here's my GCF, here's my trinomial. Exactly what the directions told me to do. Okay, part B. I'm going to divide out a 5. I'm left with, so my visual learners, put them all over 5s. So I'm left with 2x squared minus 4x plus 1. Don't tell me nothing. It's left with 1. Okay, again, do a little mental check with distributing here to make sure you can end up back where you started. All right, part C, I divide out a 4, but I can also divide out an x. This one has 3, this one has 2, this one has 1. So I can at least take out 1 x from each of those. Okay, so I put them all over 4x. And I'm going to get 2x squared minus 3x plus 5. Okay. All right, last one here. Again, what does 6, 10, and 21 have in common? I don't think anything, because this one only has 3 and 2, but 3 can't go in here, but 2 can. So you think you could take a 2 out of the 6, you think you could take a 2 out of the 10, but the problem is 3 and 7 are the only thing that comes out of 21. So there is no number they all have in common, but you can at least divide out an x from each of them. So I'm going to be left with 6x squared plus 10x minus 21. Okay, moving on. Another type of factor that you should be familiar with stems from the conjugate multiplication pattern. Remember, conjugates are opposite binomials. So these two right here, x plus 5 and x minus 5, they're called conjugates. Okay? Conjugate multiplication results in only 2 terms here. Okay? This is called the difference of a perfect square. All right? So, you have two sets of parentheses. Example 10 here, right? Each of the following binomials is the product of a conjugate pair. One's always a plus, one's always a minus. It doesn't matter if you put the minus first and the plus second. Okay? Multiplication is commutative, so is addition. And then what you do is you take the square root of both those numbers. So the square root of x squared is x. X goes in front. And the square root of 9 is 3. So x plus 3 times x minus 3 gives you x squared minus 9. You can check by either doing your box method or your FOIL. Okay? This one, be careful. You have to keep it in the order that they give you. What I mean by that is, I always put plus first for some reason. They give you the number first. So the square root of 4 is 2. So the 2's go in the first spot. Square root of x squared is x. If you were to give me x plus 2 and x minus 2, you're going to be wrong. Okay? Okay. Two sets of parentheses again. One's plus, one minus. Square root of 4 would be 2. Square root of x squared is x. So I have two x's in the front. Square root of 25 is 5. So I have the conjugate pair of 2x plus 5 and 2x minus 5. All right. This one. Two sets of parentheses. One's plus, one's minus. Square root of 16 is 4. Square root of 81 is 9. And then square root of x squared is x. So I have 4 plus 9x and 4 minus 9x. Example 11. These are just a little funky because they have fractions, but do not be scared because all you're going to do is take all the little separate square roots of each of them. Okay, so two sets of parentheses here. One's a plus, one's a minus. Square root of x squared, x go first. Now this, just take the square roots of both of those as long as they're both perfect squares, you get a half. Makes sense because a half times a half is a quarter. Okay, next one, two sets of parentheses. One's plus, one's minus. Square root of 25 is 5. Now, in the numerators, your square root of x squareds are x's. The square root of 9's down in the denominators are 3's. You just leave it like that. Okay, anytime you see this word conjugate pair also in the directions, I kind of skipped over that, you're thinking of the DPS, the difference of a perfect square. All right, so part C. So I have 1 plus, 1 minus. And it looks like I have a bunch of fractions here. So I have square root of 4 is 2 over 9 with an x. So I have 2 over 9 with an x. Because don't forget you have x squared here too. Square root of 49 is 7. Square root of 9 is 3. So I have 7/3. Okay. Now if they're not all perfect squares, then you can't do it. Okay. There's three things that are important for DPS. It has to be a binomial, which means two terms. It has to be subtraction. And everything has to be a perfect square. Okay? It has to be a perfect square. Now for the variables, in order for a variable to be a perfect square, it has to have an even power. So it's going to be like x raised to the even power. And then you just divide that by 2 to get the answer. So if it said x to the 4th, it would be x squared. If it said x to the 6th, it would be x cubed. Okay, so last one here, part D. 1 plus, 1 minus. So square root of 36 is 6. Square root of x squared is x. So I get 6 x's in the front. Square root of 49 is 7. Square root of y squared is y. So 6x plus 7y, 6x minus 7y. All right, last thing here that we have here is example 12. Factor completely means you're always going to do multiple steps. So it's a multi-step problem. Okay, so it's a two-step factoring. And one thing you want to pay attention to, it says the first type you should always do is look for the GCF. So you're always going to factor out a GCF if possible. Okay, so for part A, this wants me to do GCF, then DPS only. That's the only thing we're doing today. Okay, we move on to trinomials tomorrow. All right, so if I factor out a 5, so divide each of these by 5, I'm left with x squared minus 4. But now you should recognize that that's a DPS left over. So you have to keep the 5 out in front, and now you have two sets of parentheses. It would become x squared plus 2, x squared minus 2. Okay? All right, so 7 and 28. Factor out a 7. I'm left with 4x squared minus 1. So keep the 7. You got to make sure the 7 stays for the ride. And I have two sets of parentheses. One's a plus, one's a minus. Here's my DPS again. Square root of 4x squared will be 2x in front. And the square root of 1 is 1.